Hello, again welcome back. In this video lecture, we shall prove the theorems, theorem 1, theorem 2 and theorem 3, which I have given in the PDF notes of simple random sampling part 1. I am sorry, here I have written as part 2, but actually it is part 1. Part 2 we will discuss later. So the reference note, simple random sampling, part 1. Please make this correction. Okay, we shall prove the theorems numbered theorem 1, 2 and 3, and we shall have a discussion on how the confidence interval of the estimator of population mean and population total are discussed. Okay, now you come to the proof of the theorem 1. And you may please refer back. Proof of theorem 1 was regarding the estimation of the population mean, and we have to show that in simple random sampling, in with replacement as well as in without replacement, expectation of y bar that is equal to capital Y bar. This is we have to establish. Okay, now and the proof you write, you take this y bar, that is sample mean is equal to 1 by n sigma yi. That is, you are adding all the sample observations and you are dividing it by n, which is same as you are dividing all the y values drawn at first row, second row, third row, etc. and you divide the sum divided by n. Okay, so in these two notations, here I am using yi. Yi simply means ith unit in the sample, but here yr prime means the y value of the sample units drawn at rth draw of the sampling. Okay, so these two things are same. In fact, these two quantities are same, but the notations are different, that's all. So however, this is a sample mean of simple random sample. So what is expectation of y bar? It is equal to 1 by n. I am taking this second definition of y bar. So this is 1 by n. Expectation of y bar means expectation of this, and since 1 by n is a constant, I am taking 1 by n outside. Then expectation of the sum. Expectation of the sum is the sum of expectations, right? You take this as first equation and you pick this expectation of yr prime and you try to evaluate what is that expectation of yr prime. Now yr prime means what? It is the y value of the sample, y value of the sample units drawn at rth draw. And it may be y1, it may be y2, it may be y3, it may be y4, etc. It may be yn. And each is having probability 1 by n. What is 1 by n? 1 by n is the probability that the ith unit is selected at the rth draw and its value is written as ya. Okay, so this is ith unit is drawn at the rth draw, and you know it is equal to 1 by n. Okay, so this is summation I equal to 1 to n ya into 1 by n. So 1 by n sigma I equal to 1 to n yi, that is equal to y bar. So what you see? Expectation of yr prime that is equal to capital Y bar. So you substitute this result in the first equation. Okay, so you write this is expectation of y bar that is equal to 1 by n into sigma r equal to 1 to n into y bar, that is n times y bar by n, that is equal to y bar. Here this summation is with respect to r and the value inside the summation doesn't depend on r. Therefore, this is n times. So n times y bar divided by n, that is equal to y bar. Okay, right. And you see this result is not only valid in simple random sampling without replacement, simple random sampling with a replacement, but it is valid in simple random sampling without replacement. Why? We have already proved in the earlier video, we have proved that Pi of r, that is probability that ith unit is selected at rth draw, is 1 by capital N, not only in SRSWR but in SRSWR also. Okay, so you can see that this result is same for simple random sampling with the replacement also. Okay, so the proof is true and we have proved this theorem. Okay, now we come to the second theorem. What about the second theorem? Second theorem is a evaluation of the sampling variance of the sample mean. Okay, and this result will be different for SRSWR and SRSWOR. Later you will see this. Now we will prove this result for SRSWOR. What is variance of I bar? By definition, it is expectation of the statistic minus its expectation the whole square. That is the usual definition of variance of any statistic or any random variable. Okay. So this is equal to expectation of y bar minus capital Y bar the whole square, because expectation of y bar equal to capital Y bar. That we have proved. Okay. In SRSWOR. And next is expectation of what is y bar? Y bar can be written as 1 by n into sigma r equal to 1 to n yr prime minus expectation of y bar, that is equal to capital Y bar the whole square. Okay, then the quantity inside the curly bracket can be written as 1 by n into sigma r equal to 1 to n yr prime minus y bar. Why? Here 1 by n into sigma r equal to 1 to n y bar will be same as y bar. Okay, so expectation of this quantity the whole square. Okay, and you take this 1 by n square outside from expectation, and then you write expectation that r equal to 1 to n yr prime minus y bar the whole square. Right? And you see this quantity, the entire quantity is square of a sum. Square of a sum. And what is the square of a sum? Square of a sum is the sum of squares plus product terms that I have written here. 1 by n square already taken out. Then expectation, okay, expectation of what? Expectation of square of a sum, that is sum of squares plus all the cross product terms. I am taking all the cross product terms here. That is why I am using double summation from r equal to 1 to n and s equal to 1 to n. But the only one restriction is that r should not be equal to s. Why? When r is equal to s, it is taken here. Okay, so that is why I am writing square of a sum equal to sum of squares plus all cross product terms. Okay, now you extend this expectation into the bracket, into the summation. Into the bracket as well as into the summation. So what you get? 1 by n square sigma r equal to 1 to n expectation of yr prime minus y bar square plus r and s equal to 1 to n double summation. Then you take expectation into the bracket. Okay. Then what we are going to do is we are computing these two terms separately. You put this equation 1 and you are going to compute these two terms separately, this term as well as this term. Okay, so first we consider this term. Okay, you consider expectation of yr prime minus y bar the whole square, and that is nothing but summation I equal to 1 to n ya minus y bar whole square into 1 by n, using the usual definition of expectation of any statistic, any random variable. You know, yr prime will take capital YI minus y bar the whole square, and what is the probability that this random variable assumes this value? It is equal to 1 by n, because 1 by n is the probability that rth unit is drawn at the ith unit is drawn at the nth row. And this quantity, you know, this is nothing but the population variance. Okay, and the population variance can be written as n minus n into population mean square, because you know the relationship between sigma square and s square that we have explained earlier. Okay, in some earlier videos we have discussed this. So sigma square can be always written as n minus n by n into s square. You know, why it is. That is why I put a question mark here. Okay. Now this is the reason also I have quoted here. N into sigma square is nothing but I equal to 1 to n by I minus y bar whole square, which is equal to n minus 1 into s square. So this result is true. Okay, so you have evaluated the first term inside the curly bracket and under the summation. Okay, and similarly we have to find this value. Okay, now for finding this value you should be very careful. What is this? Here you are taking for r not equal to s. If you are taking r equal to s, then it is given here. So you need to take r and s are different because it is required here. The term required here is not for r equal to s but for r is not equal to s. Therefore, you are finding this value for r not equal to s. And what should be this? This is expectation of something. Expectation of something. That is yr prime minus y bar and ys prime minus y bar. And you know yr prime minus y bar will take yi minus y bar and ys prime minus y bar will take yj minus y bar, because this I and j should not be equal, because in simple random sampling this, if r is not equal to s, then this yi cannot be yj. That is why I am summing here I not equal to j. This is also a double summation for with respect to I as well as with respect to j. The only restriction is that I not equal to j. And into this quantity takes the value yi minus y bar and the second term takes the value yj minus y bar. And what is the probability? Probability that yr takes the value yi, that is equal to 1 by n. But what is ys prime minus y bar? It will be 1 by n minus 1. It is a conditional probability, not an absolute probability. Because in this restriction, in this summation, you restrict that r is not equal to s. Therefore, probability is 1 by n into 1 by n minus 1. Remember, this is 1 by n minus 1 and this is a conditional probability that in a previous draw, 1 unit is already selected. Therefore, there will be only n units in the population for the next rth selection. And therefore it will be 1 by n minus 1. Okay, then you can write again this can be manipulated. You can take this 1 by n into n minus 1 outside. Then this quantity is a cross product term. Okay, and what is a cross product term? Here no നോക്കൂ, നമുക്ക് ഇവിടെ നമ്മൾ കണ്ടിട്ടുണ്ട്, ഇവിടെ ഈ സ്ക്വയർ ഓഫ് എ സമ്മിന് നമ്മൾ സം ഓഫ് സ്ക്വയർസ് പ്ലസ് പ്രോഡക്റ്റ് ടേംസ് എന്ന് എഴുത്തില്ലേ. അപ്പം നമുക്ക് ഈ പ്രോഡക്റ്റ് ടേംസിന് പകരം നമുക്ക് എന്തെടുക്കാം? ദിസ് ക്വാണ്ടിറ്റി മൈനസ് ദിസ് ക്വാണ്ടിറ്റി. അതായത് സം ഓഫ് സ്ക്വയേഴ്സ് ഈക്വൽ ടു സ്ക്വയർ ഓഫ് എ സം ഈക്വൽ ടു സം ഓഫ് സ്ക്വയേഴ്സ് പ്ലസ് പ്രോഡക്റ്റ് ടേംസ്. That means product term is equal to square of a sum minus sum of squares. Okay, with that logic, you can take this quantity as square of a sum minus sum of squares. Here, this is I equal to 1 to n yi minus y bar square. Then sigma I equal to 1 to n sigma yi minus y bar square. Right? And here you can take this 1 by n into n minus 1 outside, and this quantity is 0. Why? Square of a sum. ഈ സം എന്താണ് കാണിക്കുന്നത്? സമ്മേഷൻ ഐ ഈക്വൽ ടു 1 to n yi minus y bar എന്ന് പറഞ്ഞാൽ 0 ആണ്. എന്താ കാരണം? This is nothing but the sum of the deviation of values from arithmetic mean. It is a well-known property of arithmetic mean, and this quantity is equal to 0 minus, and what is this? This is equal to, this should have been s square if it is divided by n minus 1. Therefore, this quantity you can write as n minus 1 into s square. Right? So, this is equal to minus s square by n on simplification. Okay. And now you substitute your expressions 2, that is for expectation of yr prime minus y bar square, and 3. And 3, what is 3? 3 is equal to expectation of yr prime minus y bar into ys prime minus y bar for r not equal to s, which is equal to minus s square by n. And you use this 2 and 3 in 1, you get variance of y bar is equal to 1 by n square into, okay, അത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ ഒന്നാമത്തെ ഇക്വേഷൻ നോക്കുക, ഒന്നാമത്തെ ഇക്വേഷനിലേക്ക് പോവുക, 1 by n സ്ക്വയർ പുറത്തുണ്ട്, പിന്നെ സമ്മേഷൻ ആർ ഈക്വൽ ടു 1 to n ഇവിടെ ഉണ്ട്, ഇവിടെ സമ്മേഷൻ ആറിൻ്റെ എസ് ഈക്വൽ ടു 1 to n വിത്ത് റെസ്ട്രിക്ഷൻ ദാറ്റ് ആർ ഈസ് നോട്ട് ഈക്വൽ ടു എസ്. അപ്പോൾ ഇതിൽ ഈ ഇക്വേഷനിൽ നമുക്ക് കിട്ടിയിരിക്കുന്ന രണ്ടാമത്തെയും മൂന്നാമത്തെയും എക്സ്പ്രഷൻസ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് വേരിയൻസ് ഓഫ് ഐ ബാർ ഈക്വൽ ടു 1 by n സ്ക്വയർ ഇൻറ്റു, ഓക്കെ, ദിസ്. ഇവിടെ ഈ ക്വാണ്ടിറ്റി ആറിന് ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല, അതുകൊണ്ട് n ടൈംസ് ദിസ്. അതുപോലെ തന്നെ ഇവിടെ അത് ഈ ക്വാണ്ടിറ്റി ആറിനെയും എസിനെയും ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല. അപ്പോൾ അതുകൊണ്ട് ഇത് n ഇൻറ്റു n ടൈംസ് വരുമായിരുന്നു ഈ റെസ്ട്രിക്ഷൻ ഇല്ലായിരുന്നുവെങ്കിൽ. ഈ റെസ്ട്രിക്ഷൻ ഉള്ളതുകൊണ്ട് n ഇൻറ്റു n മൈനസ് 1 ടേംസ് ആണ് ഈ സമ്മിലുള്ളത്. സോ ദാറ്റ് ഈസ് വൈ ഐ എം റൈറ്റിംഗ് ദിസ് ഈസ് 1 by n സ്ക്വയർ, n ഇൻറ്റു n മൈനസ് 1 by n ഇൻറ്റു എസ് സ്ക്വയർ മൈനസ് n ഇൻറ്റു n മൈനസ് 1 by n ഇൻറ്റു എസ് സ്ക്വയർ. ഓക്കെ, ആൻഡ് ഓൺ സിംപ്ലിഫിക്കേഷൻ എസ് സ്ക്വയർ നമുക്ക് പുറത്തെടുക്കാം. അത് കഴിഞ്ഞിട്ട് ബാക്കി ഇതൊക്കെ ഒന്ന് സിംപ്ലിഫൈ ചെയ്ത് കഴിഞ്ഞാൽ n കോമൺ ഡിനോമിനേറ്റർ എടുക്കുന്നു, കുറേ ടേംസ് ക്യാൻസൽ ചെയ്ത് പോകുന്നു. ദെൻ യു വിൽ സീ ദാറ്റ് ദിസ് ഈസ് ഈക്വൽ ടു 1 by n ഇൻറ്റു n മൈനസ് n by n ഇൻറ്റു എസ് സ്ക്വയർ. This is actually the required result for the expression of variance. Variance of y bar is equal to n minus n by n into s square. ഓക്കെ, അതിന് വേരിയസ് ഫോംസ് ഉണ്ട്. ആ ഫോംസ് എങ്ങനെയാണ് കിട്ടുക എന്നുള്ളതൊക്കെ നമ്മൾ കഴിഞ്ഞ വീഡിയോയിൽ ഡിസ്കസ് ചെയ്തതാണ്. Okay, now we stop this stage and we will prove the remaining theorem in the next video. I am doing this in order to avoid the length of the video much. Okay, thank you.